Hi everyone, and welcome to our Engineering Grand Challenge presentation by Sri Manian, Zeta Held, Jacob Sigmund, and Joey Sohak. One of the greatest challenges the world is facing today is the lack of access to clean drinking water. This problem is widespread, with around a sixth of people suffering from inadequate water supply. The target audience with our idea is rural communities, impoverished communities, and developing nations. If people are drinking contaminated water, they're likely to get sick from cholera, dysentery, or even typhoid. Um, in addition, this could lead to death if untreated. Another impact is many people cannot access readily available water, specifically people who live in rural areas. They must travel long distances to find and collect water. This is not only an inconvenience, but also places a burden on caretakers of households, who are typically women or girls. In turn, this affects the amount of education that females receive compared to their male counterparts. And this lack of education can impact the economy due to a lack of highly skilled workers. A lack of access to clean water is like a chain reaction and negatively impacts many sectors of the population. Our solution relates to this grand challenge directly, as the purpose of desalination is to produce clean water from salt water, which would benefit many people who have access to salt water but no way to purify it. With more people having ways to purify water, this grand challenge could definitely be solved as technologies get cheaper and more efficient.
So here we have a diagram example of a reverse osmosis desalination process. There are many different desalination methods that have benefits and drawbacks. Reverse osmosis is a membrane distillation technique mainly used to remove sodium and chloride from seawater. As with any desalination process, the first step is the intake of water, where impure water is taken from the ocean. As as water is collected, it is sent to the pretreatment, which is the process where solids and other large particles are removed from the water to prepare for the rest of the reverse osmosis process. Once water is free of solids, it is sent to the high pressure pump, which is used to feed water through the reverse osmosis racks. High pressure is required for reverse osmosis because of high osmotic pressure of water. The high pressure pump forces the water through a semi-permeable membrane, which separates the sodium and chloride from the rest of the water. The remaining water of high sodium and chloride concentration is sent back to the ocean. This concentration is known as brine. Once water has fully passed through the semi-permeable membrane in the osmosis racks, it is sent to post-treatment and becomes clean, usable water.
So looking at some of the challenges of implementing the solution, one is that very expensive, and especially for countries already suffering from this lack of clean water, it's going to be expensive for them. And the complex equipment that is used in this process means a lot of maintenance is needed, and this is going to be hard to do for people that don't know how to work on the machines. And it's highly energy intensive, meaning places that already don't have much money to afford energy, it's going to be worse. And you can use like solar panels, but that's just adds to the cost. And then some methods can cause harm to the environment, which is also another negative. The estimated cost and the technological challenges is that depending on the method, it could cost between $1,500 and $5,000 for one device. And using our method, it'll be on the cheaper end, but future challenges include making it more energy efficient, more or less expensive, and less complex. And can it be used outside our target group? So this solution could be utilized by anyone in need that has access to filterable water, which is really good. And the solution is not limited to a specific type of environment, making it quite versatile. So next steps is just working towards a functioning device that has implemented the features we discussed.
Some of the technology that we are planning on using would be reverse osmosis, electrodialysis, multi-stage flash distillation, and then multi-effect distillation. All these involve different varieties of desalination, and they all provide like a great way to transform salt water into clean drinking water. Our basic marketing plan could be partnering with larger and more known companies, uh, and they can help like display our solution on a widespread platform. We could use social media. It's a pretty big space to provide examples of how we could market it or whatever. We could also have it on a news platform, so it can be displayed and like shown live, and people can see the overall effect of it. Some of the problems associated with it would be to actually like gain support from a larger company. It's easy to like say it in words, but actually getting a company on board would be pretty difficult. Um, and the actual desalinization process can have some problems too, like sanitation and like rust. Um, and then also along with creating like factories and stuff like that for this, there's going to need a lot of like materials, and the product supply could be very low, so it could be difficult to make some like renovations like that.